All right, so we have already talked about absolute value families of functions. Here's your general formula. But what happens when a is something other than 1? We've only talked about when a is 1. So say you had something like this. 3/4 x plus 1 minus 2. Something along these lines. You guys know how to handle the plus 1 and the minus 2, but what's up with this 3/4? What is it? Yes, do you know what that means, if it's 3/4? Yes, the smaller a is, the wider the graph is actually. And we're only talking about the absolute value, because remember, the sign just tells you if it's right side up or upside down. Okay? So it's really the absolute value of a tells if your graph will be wide or narrow. So the smaller the absolute value of a is, the wider the graph. So obviously the bigger absolute value of a is, the more narrow the graph. So if I ask you to graph this one right here, you should be able to tell me, okay, it's a V shape. You should be able to tell me that you go to the left 1, down 2. And hopefully, okay, 3/4. That's less than 1. So if you compared this graph to a graph like we just did where a was 1, is this graph going to be wider or narrower? Well, who's smaller, 1 or 3/4? 3/4, so that's going to be a wider graph. So when we graph this one, it's going to be wider than the ones that you were graphing on the other sheet. Does that make sense? What if I gave you one that was like this? Y equals 1/3 x plus 7. Which of these two is going to be the wider graph, the 3/4 or the 1/3? The 1/3. The smaller a is, the wider the graph gets. Okay? How are you supposed to know how to make it so wide or so narrow? Well, guess what? A is super convenient because, do you have any idea what else a is besides just an indicator of wide or narrow? Yes, it's the slope. Specifically the slope of the right-hand side of the V shape. So a is your slope of the right-hand side. So how do you get the left-hand side? Well, it's the exact same thing. You just mirror it over, so you just do the opposite. So let's put this to use. If you could take a look at the sheet that I just gave you. Let's take a look at this first one here. All right, so in this first one, let me zoom in a little bit more. What is the value of a? 2. What's the value of h? -1. So again, that means we're going to go left 1. K is -3, so we go down 3. So if I ask you for the coordinate of the vertex, where that corner is going to be, where is it? If you're going to go left 1, down 3, it's going to start at -1, -3. And now we were just talking about the slope of the right-hand side. So this has to be 2. It's the same. It's exactly what a is. A is the slope of the right-hand side. So whatever you put for a, you're automatically going to say that's the slope of the right-hand side. Now think about what the slope of the left-hand side is if it's got to be the same thing, just going down, it would have to be -2. So how do we graph this? It's actually pretty easy. We're going to start at that vertex, -1, -3, -1, -3. And then, well, is this right side up or upside down? Right side up, right? Because A is positive. That's the only way to get an upside down V is if A is some negative number. But it's positive, so this is going to be a right side up graph. So I have my vertex, and all I have to do is follow my slope for the right-hand side. So if the slope is 2, what does the slope of 2 tell me to do? Up 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. Okay, you can do that a couple times. And then to get the other side, it's -2. Now don't start here and go down 2 over 1, down 2 over 1. That would get you a sideways V. You don't want that. What do you think you do from your vertex? Yeah, up 2, back 1. Isn't that still a slope of -2? You're just putting it in sort of backwards. But you want it to be, all of your V shapes should be perfectly symmetrical. You're not going to have one steep branch and then one not steep. All right, so here is your graph. Well, that wasn't so bad. Now, how does this compare to one of these ones where A was 1? Let's see, do I have a right side up one? I guess, kind of. See if I can get them both on the screen at the same time. So take a look at this pink one that we did a minute ago and take a look at this one. This one's more narrow. Now, we do have a different scale a little bit because the boxes aren't quite the same, but even if I graph them on the exact same scale, this one's going to be more narrow than if A were 1. All right? So how do you think when we graph number 2, how will that compare to number 1? Will it be more wide or more narrow? What'd you say? It's going to be wider, right? The smaller A is, the wider the graph gets. So let's see what happens. So number 2, what's A? -1/2. H is 1, so that means we're going to go right 1. K is, so we go up 2. So my starting point, my vertex would be 1, 2. Slope of the right-hand side? -1/2. So that means the slope of the left-hand side is going to be +1/2. All right. So if you have that part, you're pretty much ready to graph. So let's see. And we're expecting this to be more wide than number 1 was. So we're going to start at 1, 2. And now I always start with the right-hand side. So the right-hand slope is -1/2. So from this point, where am I supposed to go if it's -1/2? Down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Okay? And then to do the left, I'm just going to do it backwards. Down 1, left 2. Down 1, left 2. By the way, why am I not worried about solid or dotted lines and shading with these? Yeah, these are equalities. It's an equal sign. You just draw the graph. It's only if it's an inequality that you worry dotted, solid, and shading. Okay, does this seem easy enough so far? Because we're about to get a little funky over here with 3. You ready? Oh my gosh. The heck are you going to do with this thing? The problem is, it's not in the form that we're used to. It does not look like y equals some number, x plus or minus some number, and then plus or minus some number over there. It doesn't quite look like that. I've got a 2x in there. Julia? That's it. I can factor a 2 out from the beginning. So check this out. I'm going to, remember, f of x is just y, right? Same thing as y, right? So watch this. Have I changed the equation at all? No, I just factored a 2 out. Right? You can do that. You can take out a 2 and I'd be left with x minus 2. Now, you may or may not know this. You ready for this? Do you believe that I can do this? I can split those two things up. So I can take the absolute value of 2 separately, multiply it by the absolute value of x minus 2 separately, and then add the 1. And I haven't changed anything. Do you believe me? You shouldn't so easily. Here, I'll show you some examples. So let me come back to this in 1 second. Say I did y equals the absolute value of 2 times 3. And I just asked you to evaluate this, right? You would do 2 times 3 and then take the absolute value. So you would get 6, right? 6. I agree. All right, well, what if one of those numbers was negative? And I asked you to evaluate that. It's still 6, right? Negative 2 times 3 is negative 6, but then we'll take the absolute value. I still get 6. So my claim is, as long as there's multiplication in there, I can split it up and do it separately. I can take the absolute value of negative 2 and multiply that by the absolute value of 3. And I'm not changing anything. Right? Check out what I'm going to end up with. Absolute value of 2 is, absolute value of 3 is 3, and 2 times 3 is still 6. So these two are exactly the same. Does that make sense? So I have multiplication within an absolute value. I can break it into 2 absolute values.
I'm sorry to interrupt.
That's okay.
I'm doing a little experiment.
You're on video, by the way.
Just off the record. I want to know what it is. What is it? Because I have someone in my class who's on the soccer team and she doesn't know the record. And I said, you think they would know it? And she said, yes. I said, well, I'm going to go find out.
2 and 3.
Thank you.
We'll have to put him in the credits. Cameo. Okay. So you believe me? All right. So that's what I'm doing here. I factored out a 2, and then now I have 2 times this whole thing, so I broke them apart. And, of course, the absolute value of 2 is just 2, so I put a little spot for you to rewrite it. So I end up with 2 absolute value of x minus 2 plus 1. And now it is in that form that we know what to do with. All right, so that's the little trick here. You have to look at your coefficient of x. If it's not 1, you have to factor out whatever is there, and then you can split it up. Miss Abby, I thought you said this was going to be hard. Yeah, just give me a minute, okay? It gets weird. But now we know what to do. So now you can tell me what A is. 2, H is 2, so that means I'm going to go right 2, right? And K is 1, so that means go up 1. So the vertex is at 2, 1. The right-hand side slope is 2, and the left-hand side, negative 2. Oh, you didn't tell me I was at the graph. You guys are slipping. All right, now let's plot. So I'm going to start at 2, 1, and I'll do my right-hand side first. Slope is 2. So from this dot, I go where? Up 2 over 1. To do the other side, I'm going to go up to left 1, up to left 1. And there you have it. So even if it's not in the form that we're expecting at first, we can get it there. Sometimes you'll have to force it there. Okay. Ready to make it harder? Just a little bit. The next one's not as crazy yet. We're working up to it. Alrighty. Let's look at 4. This is not in the form that we're used to. Well, you're halfway right. Yeah, I want the coefficient of x to be a positive 1. Right now it's a negative 3. So that's what I'm going to factor out. I'm going to factor out a negative 3. So I'm going to have negative 3, and then what would be left behind? If you took a negative 3 out of this, what do you have? X plus 2, right? And ladies and gentlemen, if you're not very good at that, you can always go back and double check. Redistribute that negative 3 and make sure it gets you right back to where you were. But you always want that coefficient of x to be a 1. Now, we can break this apart just like I did the last one. So check this out. We're going to take the absolute value of negative 3 times it by the absolute value of x plus 2. So when I go to rewrite it in the form that I like it in, look at what happens to this negative 3. I want the absolute value of negative 3. So now it's just a 3. And then absolute value of x plus 2. And so now, hopefully, it's in the form that you know what to do with. Do you? Give it a shot. Do your A, H, and K, and then check and see if you have the same thing that I have while I do it. So when you're done, check and see if you got what I got. Does that make sense? Yeah? Everybody's good? All right. So again, H had to be a negative 2 because that's a positive 2. There is no K over here, so K is just 0, which means my vertex is at negative 2, 0. Slope is 3, left-hand side negative 3. And there's my graph. Oh. Hold that thought. Good morning, Miss Sabia. Yes. Sure. No problem. Bang. Victoria. Okay. We did all right with 4? You ready for 5? Because now it gets weird. Real weird. You ready? What the heck are you supposed to do with that thing? Oh my gosh. Oh my gosh. Any guesses? That has to be a 1. It's a 2. What are you going to do? What? No, you're right. I think if you said factor out of 2, you're right. The problem is, all right, well, 2 doesn't divide into 1. It does. It's just not nice. You have to force it. I call this force factoring. You have to do it. So, now, before we start, though, tell me something you know about this graph before we even begin. It's upside down. This thing out in front. Right now, it's a negative 1, but I'm not done because I have to do some simplifying in here. So, I don't know what it's going to end up being, but I know it's negative. So this graph will be upside down no matter what. Does that make sense? Okay. No matter what I factor out from the inside, I'm going to be multiplying it by this negative on the outside. Okay? So we're going to force factor a 2. Oh my gosh. How do you do that? Well, it's actually not so bad. I'm going to go over here so I have a little bit more room. I'm going to force factor out a 2. So here's what you can ask yourself. 2 times what gets me 2x? What? 2 times 1 is 2, not 2x. What do you multiply 2 by to get 2x? X, right? If I do 2 times x, I get 2x. Now, 2 times what gets you negative a half? Oh, shoot. I just told you. What do you multiply 2 by to get 1? A half. Here's what you're doing, guys. Whatever this number is, you have to divide each of these terms by that number. That's what factoring really is, right? If I'm going to pull out a 2, I do 2x divided by 2. That leaves me with an x. If I pull out a 2, I have to do -1 divided by 2, which is just -1/2. You're just dividing each of these numbers by whatever that number is. All right? And then I had +4 on the outside. Are you with me so far? Okay, so you force factored out this 2. That just means you have a fraction over here. It happens. So now I'm going to split it up like I have been. So I'm going to have the absolute value of 2 times the absolute value of x minus 1/2 plus 4. And then when I simplify this, what's the absolute value of 2? 2, but now this is saying I want the opposite of that answer. So it's really going to be, when I rewrite it, it's really going to look like this. -2 absolute value x minus 1/2 plus 4. Is that okay? It's weird, and it gets weirder with weirder numbers, but hopefully you can see where we're going with this. Once you get it here, now you're golden. Now you guys know what to do, I hope. So, A is -2. What's H this time? A +1/2. You can shift the whole graph just over a half instead of a whole, right? You're just going to move it a half. So H is 1/2. K is 4. So your vertex is going to be at 1/2, 4. What is the right-hand side slope? -2. And the left-hand side? +2. Now, I ran out of space on the bottom for the graph, so it's just the top one over here. So if we follow what it says, 1/2, 4. So you're going to have your vertex right about there. 1/2, 4. And then the right hand side is down 2 over 1. Now, be careful when you're doing this. Let me zoom way in so you can see. When you go down 2 over 1, it's over 1 whole unit. So I'm going to go down 2 whole units over 1 whole unit. So I'm still in the halfway zone. Get what I'm saying? Because you're going 1 whole box. If you start at a half and you go over another whole box, it's 1.5. So down 2 over 1 whole. And then we do the same with the left. Oh. And there's my graph. Are we okay so far? You ready to really get wild here? Because look at 6. What is this? How will you even do it? Oh my goodness. Well, let's go step by step. Tell me something about the graph before you even start. Something you know about this graph. It's right side up, right? Because there's no negative out here, it's going to be right side up. That's a good sign. Okay, so we at least know it should be a right side up V shape. Okay, I have to force factor here. Force factor. Actually, I'm going to do this. I need some more room. So I'm going to rewrite my equation over here. Oh, why am I wasting paper? Let's just do it on the bottom. Okay, so here's my equation. What was it? 2/3 x minus 4 plus 1. All right, I got to force factor this puppy. How? How are you going to force factor out of 2/3? You can. I just wonder if you know how. So remember what we did with the last one. It was a 2, right? And I took 2 and I divided each chunk by 2. Right? So I'm going to do the same thing. I'm going to take each chunk and I'm going to divide it by 2/3. So when I force factor out this 2/3, what is this divided by 2/3? Just x, right? Now you have to do -4 divided by 2/3. That's not so easy. but it's totally doable. I want to do negative 4 divided by 2/3. So I'm actually going to do a little bit of scratch work down here. I want to do negative 4 divided by 2/3. Well, ladies and gentlemen, how do you handle this? You do. Yes, I change it to multiplication of the reciprocal. So I'm really doing 4 times 3 over 2, which is just negative 6. Remember what you can do? You can cancel the negative 4 and the 2. You get negative 2 times 3 is negative 6. Oh, it won't always turn out so nice. But that's not that bad. So 4 divided by 2/3 gets you a negative 6. So negative 6 is left over right there. And then plus the 1. Is that all right? Have I totally lost you? Okay, some of you are with me. Good. So now I can split this up, and I'm going to have the absolute value of 2/3 times the x minus 6 and then plus the 1. So now it looks like what I'm used to. So I'll go back to my other sheet. So when we rewrite it, where am I? Here we go. Rewrite it, it's going to look like y equals 2/3 x minus 6 plus 1. And now I'm all set because I know how to handle this. This is old news. A is 2/3, H is 6, K is 1, 6 comma 1. The right-hand side slope would be 2/3, so the left-hand side is negative 2/3. And now I'm all set to graph. Ta-da! One thing you might want to do is take a look at all of the A values. Notice that any of the A values that are in between 0 and 1, they're all wide graphs. Look, that was 2/3, it's wide. All the ones that are bigger than 1 are narrow. So like this one, A was 3, it's narrow. Even on the other side, A was 2, it's narrow. Wide, because it was a half. Narrow. So the bigger A is, the more narrow it gets. The smaller A is, the wider it gets. Okay? You ready to try some on your own?